Hello, I'm Neeraj. Today I will explain the concept of tree of thoughts. Generally, we have seen with the concept of chain of thoughts that in solving the problem, suppose we have problem B, we generate the we break the problem into multiple stages. For example, first develop stage 1, it generates some output, break to stage 2, it generates some output, we break to stage 3, and then we get the final solution. Now, suppose by any mistake this stage got corrupt or we are not able to get correct stage, then it will corrupt the entire solution and we will get the wrong answer. So tree of thought generally provides solutions in such scenario, because in a tree of thoughts for each stages we will have multiple alternatives. For example, to 1 st st22, there will be multiple stages. So in stage of just depending on this, we can have multiple paths also. So we can go with this path and we can get the correct answer after checking, after applying the LLM judge or any critics. We can get this. Now let us define the tree of thoughts, the basic structure, so that we can understand. You already know that this is a binary tree structure. I'm just using this simplest structure to explain everything. So, in the tree of thoughts, first of all, we define the problem and tree of thought parameters. So, what are the tree of thoughts parameters? So, first parameter is how many alternatives you are going to select. So, here our alternatives just two. Second is depth, because if you increase the depth or you increase the alternatives, number of nodes will increase, number of relations will increase, and it will create burden on LLM and cost of the system will be high. So this is very important. After that, we create a root state and some initial frontiers. So our initial frontiers may be at depth 2 or depth 3 or depth 1, it may be anything. So suppose this is our initial frontier. This is entirely our initial frontier. And after that, we will apply and search the loop until our budgets are there. So first of all, select one stage from the frontier. So this is our frontier. So select one stage by using the search strategy. So search strategy, there are three types of search strategy we generally use: breadth first, depth first, and beam search. So you can use any one. Suppose with this strategy we selected this path. So what is the next stage? So next stage is like ask LLM to generate the K candidate thoughts. Like what may be the next stages of thoughts to solve this problem. So suppose we say that okay, generate two thoughts. So here the thought generator component that creates new thoughts, like it is created here. So this describes like this stages. Now create the child stage by adding each of the thoughts to the selected state. So we added this here. And state representation component that stores thoughts and the context. And because we added with the edges also. And after that, evaluate the child states and with the scoring rule or LLM. So here we can check both path, this path and this path both, through LLM as a judge or through some scoring mechanism, because it will generate the answer 1 and this will generate the answer 2. And once it is done, if we identify that this is the complete valid solution, if it is yes, then we will use this best solution and store in the solution path. And if our budget remains and better solutions exist, if there is no better solutions, then we can say that okay, this is our final solution. And if this is not, then what we will do, we will update the frontier. Like we say that okay, this answer one we got, this is a wrong solution based on this critique and everything. And we already have a budget. So we will go and start everything from here. So this is the process of tree of. So now let us try to understand the tree of thoughts through an example. So I will consider one puzzle kind of example. So this is a logical puzzle with multiple tricky branches. So the simplified case are like we have three friends, Alice, Bob and Carol, and each live in different cities like Paris, Rome and Berlin. Means they are not living in the same city but they are friends. So puzzle conditions are like Alice does not live in Paris. Person live in Rome, loves coffee. Bob hates coffee. Carol lives in a city whose name comes first alphabetically. Now the question is who lives where? If we try to solve this problem through chain of thoughts, then what may be the problem? Suppose we start the situation like Alice live in Berlin, and at the starting of thought process like thought 1 to thought 2, if anything misses miss at the starting, then it will give wrong result and the system will fault. But tree of thoughts solve these problems through a very interactive way and chances of errors are too less. So how tree of thoughts will solve this problem? First step will be list all the facts and constants. So what are the facts and constants? So constants are like cities name are Paris, Rome, Berlin. Friends are Alice, Bob and Carol. And what are the facts? So facts F1 is Alice does not live in Paris. Fact F2 is the person in Rome loves coffee. F3 is Bob hates coffee, and F4 is Carol lives in the city whose name comes first alphabetically. So these are the things. So how to solve this problem? So let us at the second stage, the system will start like first they will arrange the city in alphabetical order. So in the alphabetical order, Berlin, Paris, and Rome. That will be the alphabetical order. So how the tree will develop? So tree will develop like assignment tree. So this is our assignment. So first assignment will be based on that, based on the fact like Carol lives in the city whose names come first alphabetically. So Carol will live in Berlin. So this is the first assignment. Now the second possible assignment, because who lives? Two person lives, Alice and Bob, and two cities are there, Paris and Rome. Because Berlin is already booked. Sorry, Berlin is already booked. So now we can set it like this. If we say one assignment here, like Alice lives in Paris, and second assignment is like Bob lives in Rome, and another branches may be like Alice lives in Rome and Bob lives in Paris. So these may be the possible assignments. These assignments are checked and validated. Now we have to check these assignments. So here in the 3. So Alice does not live in Paris. Alice does not live in Paris. It is fact 1. So according to this fact, this branch is not possible. Now Bob lives in Rome. It is possible or not. Bob hates coffee and the person in Rome loves coffee. So both contradict each other. So this branch is also not possible. So we will discard those branches. Now we will go with this branch. Alice lives in Rome. Is it possible? and Bob lives in Paris. Is it possible? Just to check that Bob hates coffee. Bob hates coffee, but there is no information that person living in Paris whether loves or hates coffee. So it is possible to assign this part. Bob lives in Paris, and similarly, Alice in Rome. If we say that Alice loves coffee and the person in Rome loves coffee, so this is coming in favor. So this is one strong part. So this is the remaining part. We can easily validate this respect by comparing with this also. So finally, the assignment tree will develop like this. Assignment tree: Carol lives in Berlin, Alice lives in Rome, and Bob lives in Paris. So this is a way. If you have some more logical flows, then you can grow the tree like that. And after that, it will generate some paths to solve your problem. So this is the way the tree of thoughts actually works. So here you can see the final means friend list and where they're living and what are the constants satisfied that is checked. So this is based on the algorithm that we had discussed through this flowchart.